10.6, Writing Scientific Notation, we have some key ideas. So writing numbers in scientific notation involves a few steps. Step number 1 is to move the decimal point so it's located to the right of the leading non-zero digit. So as we're going through this, I'm going to fill it out and then we will go through multiple examples of how this actually works. But again, let's go ahead and write this down. So step 1 is to move. We're going to move the decimal point so it's located to the right of the leading non-zero digit. Okay, then we have step number 2. Sorry about that. All right, step number 2 is to count the number of places you moved the decimal point. This is going to indicate the exponent of the power of 10, which will be shown below. So we are going to count the number of places you moved the decimal point. This indicates the exponent of the power of 10. So numbers greater than or equal to 10, you're going to use a positive exponent when you move the decimal point to the left. When you have numbers between 0 and 1, you're going to use a negative exponent when you move decimals to the right. So as an example, if you have 137, you want to put the decimal point between the 1 and the 3. And to get from that, I need to move the decimal to the left twice. So that's 1 37/100 times 10 to the second power. Sorry, not third, second power. Now if you have decimal, if your decimal is between the 2 zeros, you want to move it between the 5 and the 6. So move the decimal to the right twice. So that's 5 6/10 times 10 to the negative second power. It's a negative exponent because my number is less than 1, while my previous example was a positive exponent because it was greater than 10. So example 1, writing large numbers in scientific notation. So Google purchased YouTube for $1,650,000,000. We're going to write this number in scientific notation. So to start, I need to rewrite that whole number again. 1,650,000,000. And I want my decimal point to end right here between the 1 and the 6, because that is my first non-zero digit. So if my decimal point is technically at the back right here, I have to move it over 1, 2, 3, 4, 5, 6, 7, 8, 9 times. So that's 1 and 65/100 times 10 to the 9th power, because I moved that decimal to the right 9. Ooh, I hit the wrong button. There we go. So example 2, we're going to write small numbers in scientific notation. So in 2004, Indonesian earthquake slowed the rotation of the Earth, making the length of a day 268 billion seconds shorter. Billionths. So we're going to write this number in scientific notation. So I'm going to rewrite it 0.12345 zeros after the decimal point, 268. And I want my decimal point to get moved between this 2 and this 6. That's the first non-digit zero. That's the first non-zero digit. So I start over from the left and I move it over 1, 2, 3, 4, 5, 6 decimal points. So this becomes 2 and 68/100 times 10 to the negative 6th power, because I went from a smaller number than 1. So on your own, we're going to write the number in scientific notation. So we have 50,000. I like to rewrite my numbers. My decimal starts on the right. I'm going to move it 1, 2, 3, 4 to the left. So 5 times 10 to the 4th power. Then I have 25 million. My decimal's over here on the right. I move it 1, 2, 3, 4, 5, 6, 7, 2 and 5/10 times 10 to the 7th power. Then for letter E, 6 and 83/100. I want to put my decimal point between the 6 and the 8. So I go to the left twice. So 6 and 83/100 times 10 to the 2nd power. Letter F. We have 5 10,000ths. When I solve that, I want to move this decimal to the right twice. Actually, I'm sorry, 3 times to make it go to the right side. So that's 5 times 10, and that was -3. For letter G, I have a 0 and then 6 zeros after the decimal point. I like to rewrite it to give myself more space and move this 1, 2, 3, 4, 5, 6, 7 times. So 3 and 3/10 times 10 to the -7th. So F, G, and H should all be negative because the numbers start less than 1. All right, you have millions, 506 millions. I want to move the decimal point between the 5 and the 0. 1, 2, 3, 4. So that's 5 and 6/100 times 10 to the -4th. So example 3, using scientific notation. An album is sold 8,780,000 copies. How many more copies does it need to sell to receive the award? Write your number in scientific notation. Well, in order to get the award, they have to sell 10 million copies. So what I'm going to do is I'm going to take the number 10 million and I'm going to subtract it by 8,780,000. Well, you can do this by hand or you can do it in a calculator. That's going to give me 1,220,000. But it wants our answer to be in scientific notation. So I'm going to move my decimal point from the very right to between the 1 and the 2. So I'm going to go back 1, 2, 3, 4, 5, 6. 1 and 22 hundredths times 10 to the 6th power. If you're questioning why I'm using a positive exponent, not a negative, my original number is larger than 10. Okay,